So I am currently working on this Unaohm Function Generator, the model EM139B. I have no user manual, neither do I have any calibration procedure for this unit. When I got it, it was as not working or an unknown condition. Several of the pots were seized up and stuck. I have loosened them up with some electronic cleaner and WD-40, so they are now fine to turn, and every pot reads good, so that's nice. And I got the unit to function, and I started to calibrate it by connect it to my frequency counter. So when working on the unit, I have it hooked up to my isolation transformer, so I can safely measure the function generator through into my counter. And as I have figured out, I'm doing this handheld, so sorry for shaking. So you got a main adjustment pot here for the frequency. Then you got one here, fine adjustment for the 1 megahertz scale. Then you got one for the 5 megahertz scale and one for the 10. So what I did, I adjusted the function generator to 1 megahertz. Hopefully you can see it like this. Then I adjusted the 1 megahertz pot as close I could get it, and adjusted the main to get in the range. Then adjusted the 1 megahertz again. Just tried and failed back and forth until I got approximately 1 megahertz there. And then I turned the function generator up to 5 megahertz, and then I adjusted the 5 megahertz pot, so I got that in spec. Then continued up to 10 megahertz. Got that in, it's not that in spec, but the scale on the function generator is quite coarse. So if you want accurate reading out, you need to connect a display or something that can, or a frequency counter to show you your frequency out, or a scope. So now I am waiting for my flux scope meter to charge up, so I can calibrate waveforms out from the function generator. I want it to be hooked up to earth in the mains when adjusting the waveforms, and not connected to my transformer. So yeah, and on my way when I was calibrating. I used my old HP counter when calibrating it, and I was a bit back and forth, connecting and disconnecting, and suddenly it stopped working and I couldn't figure out what was happening. Everything was in spec and calibrated and just stopped working. No signal out. I got power out but no waveform, and that was this calibration pot that's set here, that had broken in 2 pieces suddenly. So at first glance I couldn't see that the old pot was broken, but when I was poking around I set my screwdriver onto the pot and it started working again. And the adjustment ring had broken off, so it just fell off like this. So bad quality pots here. So hopefully the other ones won't break. So I had to change this one. So I got my scope meter hooked up to the function generator. I'm currently charging my scope meter, but this model is isolated from the mains and it's charging, so it's safe to use. I'm gonna hook up my function generator to my Unaohm function generator to the mains, not through my isolation transformer. So I need to have in mind that my circuit isn't isolated from the mains now. So that's in regards of the grounding on the case, so I don't poke around with my other meters here. So I'll turn on the function generator if I just plugged in the right cable. There. Then you can see the waveform. So I'll adjust it to 1 megahertz. So the calibration is already done of the dial, and so I am set at 1 megahertz when my dial is at 1 megahertz. So to adjust the waveform, I think I need to go to the negative and positive sin shaper adjustment. So that's most likely the adjustment of the shape of the sinusoidal wave. So I can zoom in a bit on the shape here. So the negative shape adjustment will most likely adjust the shape down here in this curve. As you can see, I adjust the shape here now. By turning this trim pot. So I want a nice curve. So I'll adjust the gain here a bit on the output. So I got 1 volt. The adjustment on the Unaohm is a bit rough, so it's not easy to get it exactly at the right frequency and voltage output, but good enough for me. So I'll try to adjust the positive side of the sine wave. So I don't have any calibration procedure for this instrument, but I think I will manage without. So it looks quite nice there. Then I'll go and adjust symmetry adjustment, I think. For that I need a square wave. So something is happening here. Maybe it's a bad cap in the circuit, because we got a rise and a fall. But so the sim adjustment will move the time period for the off, it looks like. So that's these two pots. Oh. So as you can see here, the rise starts on the line here, but it's out of calibration here. So the off time is shorter than the on time. So I have to try to get the on-off time. So I can measure it. So I got 480 microseconds on time. $528. So my off time is a bit, so I should be there about. Oh, it's so. Now I adjusted the on time. Wrong pot. So now you can see my trigger points are in line almost. So there I got off time 480 microseconds. Okay, so now all my 1, 5 and 10 megahertz are adjusted again, and my waveform is okay when using this function generator. I will always hook up a scope or a frequency counter to adjust my wave out. So because the dial is so coarse that it's hard to dial in exactly the frequency with only looking at the dial here, but yeah, the waveform is good on the output from the function generator. So now I'm gonna take a look at the auxiliary out. And adjust the calibration pots on this side, this board here. So I forgot to tell you about what you should start with. That's the input voltage adjustment. Then it should be 17.2 negative and 17.2 volt DC positive on from the power supply. That's adjusted here, positive and negative, and you measure it on these 2 points here with your multimeter. So I can show you how I do it. So it's always good to have the voltage calibrated before calibrating the waveform and the frequency. Find some clips to put on. I just ground the meter to the chassis. Then I can measure a negative output, 17.2, then the positive, 17.2. So I think it's a wise advice to calibrate these voltages before going any further. So here's the waveform on the auxiliary generator output, and I had set the gain to multiplier to 10k, frequency fine adjustment is set to cal, and the sum is set all the way down to the bottom scale. So here you also got the negative and the positive sin shaper. So that's for adjusting the waveform, and it looks quite nice where it sits, but I can adjust it so you see what's happening. So this is the negative adjustment. Can zoom in a bit. Then you got positive adjustment. So as you can see, the shape of the waveform is adjusted. So there. Then you got balance adjust, and you got sim adjust. So I think I need to go into the square wave for a sim adjust. So that's the time for off. Off time on the square wave or waveform. This balance adjust doesn't do anything here, so then I need to measure my on time to get the off time correctly. There. So there is my on time is 52 microseconds. Then I go to off time. That's a bit too low. Need to move it. So I get everything on my display here. So 52, wasn't it? So that's quite a difference. I wonder if it should be at exactly 10 kilohertz at the calibration point. That seems right. So I have adjusted it to 10 kilohertz without measuring with my cursors on the scope meter. So I think that's correct way to do it. Yep, now I have 1 hertz here. So adjusting it to 10 kilohertz at 10k multiplier. That's and the adjustment to cal seems the correct way to do the adjustment. Square wave or the triangle wave looks nice. Square wave looks nice. The sine wave looks horrible. Why? now the sine wave is okay. So it can be the switch that is acting up here. Weird. So it's an old instrument. So before I started the calibration, I also took out all the ICs and sprayed it with some contact cleaner. So I don't know how long this has been standing and at what environment, so before I got it. But it seems that everything is working now as it should. Now I can adjust the gain on the AM modulation. That's quite nice. FM modulation. There you can see it. It's modulating. And you got the SW. So yeah, it looks like the function generator, Unaohm Function Generator, is working nicely now and is calibrated good enough for my use. So this is most likely not the right procedure to do the calibration, but it works, and I don't have any calibration papers or to follow. Neither do I have a user manual, so I have hooked the Unaohm Function Generator onto my electronic counter here. So let's power it up. Now I'm connected to the isolation transformer again, so I don't F up my instruments. Alright, Unaohm is connected to the isolation transformer. So turn it on, and we are at 1 megahertz there, and we got 1 megahertz on the counter. Dial up to 2, 3, 10. It's a bit low at the 10. That's easy to adjust. So the Unaohm goes up to 13 megahertz. So we can get a bit more decimals on our reading here. So there we are at 1 megahertz. It is not easy to dial in with this adjustment here. Just a small touch on the adjustment and it's way up or down. So now we are at 100 Ks. One K. So that's 1 kilohertz signal. Can turn it up to 5. See, the Nixie tubes are doing its job. Can go all the way down to 10 Hertz. Reset the counter. So 50 Hertz there. Bit over. Six Hertz, 60, 70, 100 Hertz. So this HP 5245L electronic counter is quite a nice equipment. It's calibrated also in 2009, so or 2008. So it's quite in spec. So yeah, that was the repair and calibration of the Unaohm, or mostly calibration. So hope you liked the video. See you next time. Bye.